Hello guys, today we are gonna start to a new method or the topic in the system dynamics or the mechatronic engineering, which is the name of the control of the wheel model techniques. Especially in the control theory, we have several methods to be utilized in order to control the system or to track the system for a given reference problem. Okay, and so in the previous lessons we have talked about how can we obtain the wheel model by using the system dynamic approach, but however we need to control it or drive it to specific point of the reference. Okay, and so the control theory can provide us to build this kind of equations in order to set the proper action force or action input. Okay, and so in order to give the introduction section, we need to utilize some example model, which is we are using the wheel model in our lesson. Okay, and so in order to create a control method on this system model, we need to firstly create the system dynamics model. Okay, model. Especially we need to build the equation of motion, and it's related to transfer function and state space approach. Because if you don't have an equation to represent the wheel model in the maths, and so we cannot predict the value of this dynamic equation of motion. Okay, and so as well as we cannot control it, or we cannot build some basic rule on driving the reference problem. Okay, and then we need to understand the control theory in here, which includes to what the PID controller or full state feedback controller or LQR controller. But in this lesson we will only focus on how can we establish the PID controller on this wheel model mode. Okay, and then we need to create the transfer function methods to condition or drive or change the output or the input variable by using what? By using the controller equation. Okay, because if we have a system to be controlled in our model, and then we should change or set the input variable or action variable or across variable by using what? By using the TF system modes or transfer function modes or the state space function modes. And so the PID, full state feedback, and the linear quadratic regulator can be used to condition this system to be created for the input variable. And finally, we need to create a system model in MATLAB Simulink application in order to test the efficiency of what? Of system response. Okay, these are main course of this study, and so we need to build in the first place the system dynamic model, and so the control theory can be explained in order to understand the PID controller and full state feedback controller and LQR controller. In this lesson we only create the form of the PID controller in terms of the transfer function method. And so we can create a reference tracking problem in here, which means that we have a reference signal in here, and so the system should be track this reference signal by using the input variable, which is based on what? The controller equation. Okay, and so after that, in the theory, we should build the MATLAB Simulink application in order to represent the system dynamic model as well as the controller input equation. Okay.